The topic we were given for discussion is biodiversity. And as usual, since we represent Artral Evolution Library, we wanted to see how the diversity and the biodiversity evolved in nature. So, the biology, how it would have evolved is from the basic periodic table of elements or from a set of atoms. So we asked ourselves a question how the atoms themselves would have evolved in nature. So let's take back a step a few billion years back when there was only the singularity or the Big Bang era, when the space had nothing and there was no dynamism outside of that singularity. So if now nature wants to introduce some kind of a dynamism, let's assume first it introduced an electron and the negative representing some kind of a charge on it. If there is only one electron, literally nothing happens again, still there won't be any dynamism. Now let's assume the nature created another electron with a similar charge. Then what could have really happened is, because there is some kind of concept called charge, they would have repelled each other and then spread to the ends of the universe. So again, it goes back to rest. Another option could have been, what happens instead of a negative charge, I put up a positive charge, the first level of diversity, a different kind of a charge. So negative and negative as it repelled. Now with negative and positive, there could have been extraction, and these two would have come together, and again there could have been a concept of rest, only rest, and there is no more dynamism. Now, how do we create diversity with only these two elements? So this was the beautiful question or a challenge which would have been there in front of nature. So in order for nature to introduce dynamism, we thought about two perspectives. One was how data is stored in computers as in digital data using ones and zeros. And another perspective was if we have an opportunity to introduce something called as a rotational motion. So these two we thought might be two different perspectives. So first, let's say rotational motion. You can imagine, you can visualize this ball which is just hanging here straight down. But if I give it a spin, I can leave it in a different plane. Okay. Similarly, I can also do this in vertical direction. So as long as this object or the electron, any object can spin around, it can stay in an orbital. If that is not provided, it falls back and again gets stationary. Okay. So this is one example. So one option is to go for a rotational motion like this, so that there can be dynamism which is there. This is one perspective. The second perspective we looked at was, like in digital storage, let's say I have a switch. So how much of information can I store in this one? Either on or off. So only two information can be stored. If I have two switches, okay, so this can be either on, off, off, on, and then off, off. So we can have four states which we can capture, or four informations. Similarly, if I have three switches, I can have, I'm not writing the whole thing, you can have 8 combinations. So mathematical formula to this comes to 2 power n. If I have only one switch, 2 power 1 is 2, which means I can store 2 informations. If I have 2 switches, I can have 2 square, which is 4 informations. If I have 3 switches, 2 power 3, which is 8 informations. So if nature had only these two, one electron and one proton, maximum it could have only 4 informations which it could have stored. Now comes the rotational principle to the help of nature like this. With that, the amazing thing is just with adding one more element, one more particle called neutron, which is neutral, nature is able to create the whole of the periodic table, which has at least 108 elements. Some people say it's 118, but we can say it's anything more than 100. So just with 3 elements, beautifully nature is able to create more than 100 elements. We will see how that works. So with this in context of this rotational motion, let's see how nature would have created the periodic table of elements. Let's say there is a bowl into which we take one proton and then put it there, and then we allow an electron to go around. So this dynamism can keep on happening. So this is the only rule. Okay. So now going to the next step. So we call this as hydrogen. Now let's introduce one more. How do we incrementally add up? Let's say we put 2 protons, and then we can have 2 electrons going around in orbitals, orbital cloud. That's how we are supposed to be visualizing. For simplicity, we are saying electrons go around in orbitals like a particle. But with this method, there is one new problem. This proton, 2 protons, if I put them near to each other, they will repel and run away. So somehow I have to find a way of how to keep them together. So nature identifies one more element called neutron with no charge, and then if I put 2 neutrons, this can act as a glue, and which will keep all the protons in the nucleus of the atom, and then I can start distributing electrons around. If we take carbon as an example, which is the basis, the smallest atom with 4 electrons in the outermost orbital. If we want to have carbon, it requires 6 protons. So for the glue purpose, we need 6 neutrons, and we can have 6 electrons. This is the first orbital, 2, and in the second orbital, we can have 4 electrons. So this way, you can take any example, oxygen, nitrogen, gold with 79 protons, and it goes so on and so on. So this is the beautiful way nature would have evolved the elements in the periodic table itself. So this is how we come across like basic atomic diversity. And in the next session, we will talk about how biology would have got created from this basic elements and what has resulted into something called as biodiversity.